morning, all of you. Good morning, a very good morning to all of you. Thanks for joining in early in the morning. As I understand that this lockdown period, most of us we stay at home throughout. Whole day we stay at home. So I understand that whole day we use the mobile, and then by evening time, what happens is our data limit or the daily data limit is already over. So that's why I'm conducting the classes early in the morning, so that the rest of the day you can freely use your data. So that's the reason why I have conducted early in the morning, and thankfully many of you are joining in the classes. So that's good to see. So, as mentioned earlier, we will start off with the class 12 syllabus. So, we'll begin first with I cannot say a simple topic, but a more interesting topic which will give us a better, it'll help, something like class 12 mathematics. So, we all assume it's going to be complicated, something like that. So, let's start with something more relaxing, more fun to study. Okay, so we'll start off with matrices. This is not, nothing is easy. I cannot say that it's going to be easy, but like it's more interesting. So we can start with the softer things first, and then after that, okay, slowly we'll get into the bigger part. But yes, do not take matrices lightly. That's one thing you should always understand. It's easy, it's simple, but it can really complicate you. Okay, so let's take, every topic is important, so we will take every topic very seriously. So I believe that you have your pen, paper, books with you. Textbooks, I do not know whether you have it or not, but nevertheless, it won't matter. So we will start off with the topic matrices. Of course, this is the plural form of matrix. So singular form is matrix. And when there are many matrices, 2-3 matrices, then in plural form we call it as matrices. Okay. Now, what is a matrix? It has many varied applications in computer science, industries, and all. But of course, we are not going to be learning all those as of now. We'll be just trying to learn the basics of matrix algebra. In some of its applications, some of its properties, and after that, when you go for your higher classes like engineering or graduation and all, there of course you will see another paper on matrices. From there, where we will be learning more of matrices. So here in class 12, we will just try to learn the basics of matrices and its basic algebra. Okay, but before that, what is a matrix? Now, a matrix is nothing but, you can write on the definition as I give you also. It's something like a rectangular array of numbers. A rectangular array of numbers or functions. Not only numbers, functions also. A rectangular array of numbers or functions in the form of, good morning all of you, in the form of m horizontal lines, in the form of n horizontal lines called rows, and n vertical lines, which are also known as columns, and n vertical lines, also known as columns, is called a matrix of order. I'll talk about this in detail. As of now, just let's first write down the definitions first. Of the order m by, it's like m into n, or it's basically named as m by n. Okay, so that's how we will be naming the order of the matrix. The matrix m by n. Yeah, it's called a matrix of order m by n. Simple as that. Let's not beat around the bush too much. Let's just get straight to the point. So, what is a matrix? A matrix is a rectangular array of numbers. Why do we call array? That also I'll tell you. But first, write down the notes first. Definition. So, a rectangular array of numbers or functions in the form of m horizontal lines, which are also known as rows, and n vertical lines, which are also known as columns, is called a matrix of order m by n. Alright, so I think that part is done. So now, basically, what is a matrix? Okay, that is a definition, but matrix is something like, as it is mentioned, a rectangular arrangement. So something like, if we talk of numbers, let's say 3, 4, 5, 2, 1, 3. So this is a rectangular arrangement of numbers, isn't it? In terms of rows and columns, horizontal lines and vertical lines. So a rectangular array. Why do we call it array? Because why do we call it an array? Is simply because of the fact that it is arranged. The numbers are arranged in the form of a tray. It is generally basically denoted in this bracket, like a tray. That's why it's called array, arrangement in a tray. Okay, that's why it's called array, arrangement in the form of a tray. So this is how we represent the matrix. So an arrangement of numbers or functions. Functions also something like this. It can be functions also like cos x, sin x, tan x, minus sin x. So an arrangement of numbers or functions or letters, anything in the form of horizontal lines and columns, and vertical lines is known as a matrix. Now, we generally use this bracket, okay, the box bracket. Or yes, sometimes we use this bracket also, like this, 1, 2, 3, 4. We can use this bracket, but more commonly, of course, we use this box bracket to denote a matrix. Got that? And yes, it is basically denoted by capital letters, just like sets. Just like sets, this is also denoted with capital letters. We don't use small letters to denote this matrices, okay? So we will be using capital letters. It's basically just like sets. Just like we will be using capital letters to denote matrices also. Alright? Now, as per the definition, once again, a rectangular array or arrangement of numbers or functions in the form of m horizontal lines. These are horizontal lines. So these are known as rows. We call this as the first row R1. This will be R2. So we basically see here how many rows? 2 rows. And n vertical lines. So how many vertical lines do we have here? 1, 2, and 3. So these are known as columns. C1, C2, C3. So basically here, how many rows do we have? We have 2 rows. And how many columns do we have? We have 3 columns. So in that case, the order of the matrix is written as 2 rows, 3 columns. So it's 2 by 3. Alright. So this is a matrix of order 2 by 3. Always remember rows first and columns. Rows by columns. Rows by columns. Rows by columns. Or length by breadth. Isn't it? Rectangular arrangement. Similarly here, if we talk of this matrix, what is the order of this matrix? The order of this matrix is how many horizontal lines do we have? 1, 2. So we have 2 rows, R1 and R2. And how many columns do we have? We have 2 columns, C1 and C2. So this is of the order 2 rows by 2 columns, 2 by 2. Fine? Alright. So basically that's what is a matrix. So it's nothing, it's just a rectangular arrangement. Of course we have different types of matrices, we'll be studying all of that, but it's nothing but just an arrangement of rectangular arrangement, just arrangement of numbers or functions in terms of rows and columns. Just like assembly ground, when you study in terms of rows and columns. In the classroom, you see the benches arranged in terms of rows and columns. These are all part of matrices only. Okay. Alright, so as I have mentioned, what is a matrix? How do we denote its order? Its order is generally denoted by the rows and columns, rows by columns. Then of course how we usually denote by within these two brackets, box brackets, generally the first one, and the order we name, and of course yes, we will be using capital letters. So these are the basics from where we will begin with matrix. So I believe now we can all name a matrix, isn't it? What is a matrix? How do we denote it? How do we represent the matrix? So I believe that is fine. Now, in general, elements of the matrix. So in general, let's see. So in general, how shall we represent a matrix of order m by n? Generally, generalizing a matrix. Okay. So that means it has m rows and n columns. So, but yeah, before that, as I gave you those elements like 1, 2, 3, 4, 5, 6. Now, what will be the order of this particular matrix? The order of this particular matrix will be like what? 2 by 3. 2 rows and 3 columns. So that means how many elements do we have? Elements do we have in this matrix? We will have 6 elements. All these numbers are called its respective element, the respective element of the particular matrix. So this is first, second, third, fourth, 5, 6. So even the order also gives us an idea on how many elements can a matrix have. 2 by 3, so 2 into 3, 6. So we can have 6 elements maximum. We will have 6 elements. So how do we name this element? This is the element. Okay, this is the element which is lying in the first row, isn't it? R1, and first column, C1. Is it? So this element, I'll just write here, this element will be written as A11. Element lying in the first row and the first column. Similarly, this element is lying, of course, in the first row. And which column? Second column. So likewise, we'll be naming our element. That is how we will be representing or naming an element in a matrix. And that's how we will identify the elements in a given matrix. Similarly here, this is first row, third column. So that basically requires a little bit of your presence of mind, your sense or the common sense. This one. This will be represented by what? This is lying in the second row, A2, first column, A21. Similarly, this is lying in the second row, second column. This, second row, third column. Simple as that. Alright? Now, in general, how shall we represent a matrix, generalizing it? So generalizing a matrix will be of order m by n will be, you can just have a look at this, generally. Okay, in general I'm writing like A11, A12, A13 dot dot dot. This has how many? M by n. M by n means it has m rows, that is A21, it will go on till AM1. It has how many rows? M rows and n columns. So the last column will be A1n, isn't it? Similarly, A21, A22, A23 dot 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 A2n, because it has n columns. So these are columns. So columns will be up to n. Rows, these are rows. Rows will be up to m. So last one will be what? AM2, AM3 dot dot dot. Last will be mth row, nth column. Mth row, nth column. So in general, of course, we can also write here maybe ith row, jth column. So in general, what happens is we will be just naming this matrix as Aij in general, m by n. That is how we represent a matrix in the general form. That is Aij m by n. So this represents a matrix of order m by n. Aij represents the elements, which it will depend on the number of rows and columns that you have. How many elements shall we have in the given matrix? Alright, so that's basically how we introduce a matrix. So I hope that's fine up to some extent. Now let's try one particular problem with the basics of matrices. After that we will have different types of matrices. Okay, so you can write down one question that is like a simple question for your practice, that is construct A. Construct a 3 by 2 matrix. Construct a 3 by 2 matrix whose elements are given by Aij. The general element is represented to you as I plus 2j. So let's try to construct that particular matrix. So solution. Now let's sort out a 3 by 2 matrix. How will that particular matrix be? A 3 by 2. So that's like 3 rows, 2 columns. 3 rows, 2 columns. So 3 rows, 2 columns. So it's going to look like something like this. 3 rows. 1, 2, 3, 2 columns. So this is exactly how our matrix is going to look like. 3 rows, 2 columns. So now let's name the elements. So in that case, we will be having elements of A11, A12, A21, 22, 31, 32. So that's exactly how our matrix will be looking like. So the general element is given to us as Aij representing I plus 2j. Now your simple job is just to find out A11, A12, A21, 22, and so on. So let's begin. So let's find out A11. So A11, if we use the general element, 1 plus 2 into 1. So that's going to be like 1 plus 2. That will be 3. Similarly, I need A1, 2. Isn't that A1, 2? Okay. So that's going to be like A1 plus 2, 2. So 2 2s are 4 plus 1, 5. Similarly, A21. 2 plus 2 into 1, so that's 4. A 2, 2, 2 plus 2 into 2 to the 4 plus 2, that's 6. Let's try to find out A, what? I need 3, 1, 3, 1, 3, 1. So 3 plus 2 1s are 2, 5. A 3, 2. So like 3 plus 2 2s are 4. 3 plus 4, that's going to be what? 7. So finally, our elements are already prepared, so we can have our required matrix. So then our required matrix, what was it? It should be looking like A1, 1. So this is A1, 1. 1, 2, where's 1, 2, 1, 2, 1, 2, 5. 2, 1. 2, 2. 3, 1. 3, 2. Bus. Of the order 3, 1, 2. So it's simple as that. So that's how we'll be constructing a matrices. A matrix. This is just one matrix now. Of the order 3 by 2. Okay. One more question. Let's have a look at this question. Like say if a matrix has 12 elements, if a matrix has 12 elements, what are the possible orders it can have? If a matrix has 12 elements, what are the possible orders it can have? Think. So it will have 12 elements. So what are the possible orders that it can possibly have 12 elements? So the possible orders are, like, it can be of the order 12 by 1, isn't it? That means you'll have 12 rows, just one column. So definitely it'll have 12 elements, 12 rows, one column. What are the other possible orders? Likewise, if you think, we can have 1 by 12 also. We will be discussing about this type of matrices also. 1 by 12. Is it so slippery? 1 by 12, then in that case we'll have just one column, 12 rows. I mean, one row, 12 columns. Likewise, we can have the order 6 by 2, 2 by 6. Then we can also have 3 by 4, 4 by 3. So these are the possible orders that we possibly can have if a matrix has 12 elements. Fine? Alright? Okay. A simple question, of course, a basic question. My dear students, please do remember this is the 12th standard. So, and I'm sure that this year also your classes will be on and off. So, please do remember that there cannot be any excuse this time. No matter what the situation is, you will still have to survive. As the saying goes, it's all about survival of the fittest. Everything is all about survival of the fittest. So you can whine and complain and cry, but nothing is going to help you out. Okay, so you have to help yourself. So please do work right from the beginning. Anything that begins well, they will definitely end well. And class 12 syllabus is not a small syllabus that you can just cover it in 1-2 months. Not like class 11 syllabus. Also, it's huge. It's humongous. So you have to begin right from the start. Okay, otherwise it's going to be impossible to wind up with the syllabus. So please do give importance. Next up, since we have already learned now the basics of matrix, how do we represent a matrix, what is a matrix, here we will see the various types of matrices. Various types of matrices, simple matrices. So first one, we have the row matrix. Alright, we have the row matrix. So I'll just give you in short maybe an example only, because if I give you the definition and then it might take a very long time and all. So let's skip that part. You'll have it in your textbooks also. Right, so I'll just do the explaining. Maybe I'll give you some examples only, so you can note down also as I dictate also. That also will help. Alright, so it's a simple thing. Row matrix, what is it? This is nothing but a matrix which has only one row. A matrix having just one row, but it can have many columns. So a matrix having just one row is known as a row matrix. Bus. So for example, like A, a matrix with one row, 4, 5, 6. See to it that you write it arranged. Okay, so like this is one row, 3 columns. So a matrix having just one row is known as a row matrix. Similarly, we will have column matrix. So I guess you can guess. Lots of guessings. So column matrix, what? The column matrix is a matrix which has, yes, one column. But so that's example would be A. One column, many rows. 1, 2, 3, 4. So this is basically a matrix of 4 rows, 1 column. Remember always rows by columns, rows by columns, rows by columns. So this is the example of a column matrix. Then we will have number 3, 0 or null matrix. So I guess you can guess this also. Lots of guessing again. What will be this? A 0 matrix or a null matrix is a matrix in which each of the element, no matter what row it is, in which each of the element is 0. So like example like 0, 0, 0, 0. So basically we will be denoting a zero matrix by capital O. So whenever you see this O in matrices and all, do remember that it represents a zero matrix of a definite order. What order? That will be discussed later on. So we have the row matrix, the column matrix, the zero matrix, plenty more to come. The square matrix, number 4. I guess you can guess this also. Square matrix, square. What was the definition of a matrix? A rectangular array, a rectangular arrangement, a rectangular. Because the number of columns and rows, there is no hard and fast rule that the number of columns and rows should be same. If in case the number of rows and columns are same, we call that as a square matrix. Where, since we're denoting the number of rows by m and columns by n, if m is equal to n, that means if the number of rows is equal to the number of columns, then it's simple. It's a square matrix. Example, let's say A, 2, 3, 3, 2. So this is an order of what? A matrix of order 2 by 2. So it can be of order 3 by 3, it can be of order 4 by 4. Got that? But then, yes, we have the next, that is the diagonal elements. Diagonal, not matrix, elements. Diagonal elements of a matrix. Now basically, for example, if we have a matrix A, 1, 2, 3, 4, 5, 6, let's say of order 2 rows, 3 columns. Now diagonal, how many elements do we have here? 1, 2, 3, 4, 5, 6. We have 6 elements there. Now, what are diagonal elements? Diagonal elements are those elements where I is equal to j, where it belongs to ith column, jth column. I equal to j. I equal to j means like diagonal elements are those elements where I will be equal to j. Okay, so the elements for which I is equal to j are known as diagonal elements. So in that case, like A11, no? Diagonal elements, A22, A33, A44. Of course, we'll not be dealing with such a big matrix, but like where I is equal to j, the matrix in which the element for which I is equal to j, those elements are known as diagonal elements. Because so far we have been studying diagonal elements are like diagonal like this, it can be like this and all. So that will create a lot of confusion. So that's why simple, when I is equal to j, those kind of elements, those elements are known as diagonal elements. So in that case, A11, A22, but we have only 2 diagonal elements here. A11, got that? A11, this is A22. So these are the only 2 diagonal elements. Because here, this is A31, so I is not equal to j. I mean A13, so I is not equal to j. Here this is A21, so definitely it's not, I is not equal to j. So only where I is equal to 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, simple. Those elements are known as diagonal elements. Got that? Alright. Then, with the concept of diagonal elements of a matrix, we will see what is a diagonal matrix. This is number 6 is it? Diagonal matrix. What is a diagonal matrix? This is like a square matrix. Okay, let me just give you this. A square matrix. A square matrix in which every non-diagonal element, a square matrix in which every non-diagonal element is 0. is called a diagonal matrix. I guess you can understand that, right? So, like for example, 6. Every non-diagonal element is 0. So 0, if we go for a 3 by 3 matrix, for a square matrix, 0, 3, 4, 0, 0, 0, 5. I do not know whether you have noted down or not, because as I was writing down, that's why I gave you the definition. As I was noting down the definition, when I started with diagonal matrix, you must have seen a square matrix. Square matrix. That means diagonal elements, one condition is that it has to be a square matrix, where the number of rows and the number of columns should be same. It just cannot be in any matrix, rectangular matrix, where the number of rows and columns are not same. No, it cannot be that. Okay, for a diagonal matrix, condition is it has to be a square matrix. Then only we can proceed. So a square matrix in which every non-diagonal element is 0. So this is a square matrix of order 3 by 3. Every non-diagonal element is 0, and that's why this kind of matrices can also be written as, in short, diagonal, where only the diagonal elements will be mentioned to you. So from there, you should understand that this represents this one. So sometimes what happens is in the exams or somewhere else in the question papers and all, instead of giving you a 3 by 3 matrix, they will just give you this only, a diagonal 6, 3, 5, and maybe they will just tell you to add this matrix with a 3 by 3 matrix. So for any student who doesn't understand that concept, he will have difficulty, because we know that, we'll talk about this in the next video of course, but we know that for algebra of matrices, if you have to add matrix, it has to be comparable, equal, and so on. So you should understand that diagonal matrix, there are 2 ways to represent. Either this or this in simple form. Alright, we'll be studying about those matrices now very soon. Next is number 7, that will be, let's say, a scalar matrix. What is a scalar matrix? So a scalar matrix is a square matrix in which every non-diagonal element, it's a diagonal matrix only, okay, in which every non-diagonal element is 0, okay, it's 0, and all diagonal elements are same. So this time yes, it is a diagonal matrix. Every non-diagonal element definitely will be 0. Here the condition is the diagonal elements should be same. 5, 0, 0, 0, 5, 0, 0, 0, 5. So this is a scalar matrix. Fine. Next up is unit matrix. This is important because we'll be doing this every now and then. So a unit matrix is nothing, again, a square matrix in which every non-diagonal element is 0 and every diagonal and all diagonal elements, and let's say every, that will be more specific, and every diagonal element is 1. This is called a unit matrix. So here every scalar matrix, all diagonals were same. Unit matrix, another condition is that every diagonal element should be 1. That's why it's called a unit matrix. Simple as that. Every diagonal element is 1. So these are generally denoted by not just ordinary letters. This is generally denoted by I in matrices. So whenever you see this I, remember it represents a unit matrix. Sometimes they will just give you this only, I3. So in that case, it represents a unit matrix of order 3 by 3. If they give you I2, then it represents a unit matrix of order 2 by 2, like this. Alright, so remember 0, the letter O, capital A matrices will represent a 0 matrix. I will represent a unit matrix. Fine? Alright. Done? Fine. Next. Next up, this is what, like number 9, I guess. Comparable matrices. COMPARABLE. Comparable matrices. What are comparable matrices? Two matrices are said to be comparable. In short one, are said to be comparable. Okay, let me just write down two matrices are said to be comparable if they are of the same order. So in matrix, we will be able to compare matrices if and only if they are of the same order. So if they are not of the same order, then there is no comparison, no addition, no subtraction. Multiplication is sometimes possible, but that we'll study later on. So these are known as comparable matrices. So we can compare matrices only when they are of the same order. That's like if you have two matrices A, 3, 2, 1, 0. We have another matrix B, 1, 2, 3, 4. Yeah, then in that case we can say that they are not equal comparable matrices. Comparable matrices because they are of the same order, so fine, that's it. Alright, then comes equal matrices. And this one I guess everybody can guess what it is. Equal matrices are what? Two matrices are said to be equal if they are of the same order. That's one thing for sure. If they are of the same order and equal, and their corresponding elements are equal or same, and their corresponding elements are equal. That's equal matrix, nothing to be confused here. So if A is 3, 2, 1, 0, then if B has to be an equal matrix for A, then simple. You don't have to guess also here. It should be, only when the corresponding elements are exactly same, equal, then we say that A is equal to B, nothing much. These are known as equal matrices. Alright, so these are the types of matrices that we will be coming across. Many more, of course, we have symmetric, skew symmetric, we have many more matrices to be discussed, but these are the basic matrices. Okay, so the basics of matrices, some few concepts. Now, that's basically up with the first session. I'll give you one problem. Let's just solve one particular problem. That is like one question, that is find x, y, z, x, y, z, when 5, 3x7 is equal to, remember box matrix, okay, better, y, z, that's more common, and it has to be arranged. The number of rows and columns has to be arranged, because that's basically what is a matrix, arrangement. So if you don't arrange, then it's not a matrix, simple as that. Arrangement is very necessary. So find x, y and z when you are given two matrices. So it's very simple, even though it's not, this is the class 12 standard, so we can assume. It's given very clearly that these two matrices are what? It's given here. What is this? What is this? What is this? Equal. It's clearly given that those two matrices are equal because they are definitely of the same order, and it's given here equal matrices. Every time you don't have to mention. But since the corresponding elements of equal matrices are equal, what shall we have? 5 is equal to y. Done. Corresponding elements. 3 is equal to z. X is equal to 1. And lastly, exactly 7 is equal to 7. So that's basically what do you mean by equal matrices. Two matrices are said to be equal only if their corresponding elements are equal. Yes, provided of course they are of the same order. That's it. So today, as we have seen, we have learned what is a matrix. No, it's a rectangular arrangement of rows and columns. Rectangular arrangement of numbers or functions in terms of rows and columns. We have seen how do we name the matrix using box bracket. Generally, we use capital letters. And how do we represent the order? And how is order related to the number of elements in a given matrix? Then, of course, we have seen the different types of matrices. We have the row matrix, we have the column matrix, we have the zero matrix, which is important. We have the identity matrix, we have the square matrix, number of rows is equal to number of columns. We have the diagonal matrix, where all the non-diagonal elements are zero, only the diagonal elements are present. What are diagonal elements? Where I is equal to j, like a11, a22, these are known as diagonal elements. Then we have seen what are comparable matrices. Then finally, of course, we have seen what are equal matrices. So this will form the basic foundation for your for you to proceed with matrices. So tomorrow, in the next video, next session, what we will do is we will be learning on algebra of matrices, like how do we add matrices, how do we subtract matrices, how do we multiply a matrix. That's a little bit of a complex part. How do we multiply a matrix, and many other functions. So those will be discussed in the next session, that is algebra of matrices. So that should be enough for today. So thank you all for joining in. And hopefully I'll see you tomorrow again. So please start preparing, and yes, please do stay safe. Wear your mask every time, and please do stay safe so that we can study properly. All right. So yes, if you still haven't liked the video, at least give me a like idea somehow. Anyway, all right, then see you tomorrow. Thank you all for joining in. I'll see you in the next session, that is most probably tomorrow. All right, take care, all of you. But before that, any query, any doubts, anyone? Just before we wind up. A nice day. Have a great day, all of you. But anybody has any doubts, clarifications to be made? Your cooperation, of course, is more important. So, most of you are so eager to learn. So, definitely, I will be very encouraged to teach you. That's one thing for sure. So, I guess, of course, there is no specific doubt, because it's just the introduction class only, isn't it? All right, then. I'll see you hopefully tomorrow with the algebra of matrices. Bye bye. Take care. Yes. Stay safe.